Who's ready for another episode of Pico-8pril as Family Geekery presents Pico-8, and this week we're finally going to learn about loops. Hey everybody, it's Chris from Family Geekery, and in this episode of our Pico-8 tutorial series, we are going to tackle the big, important concept of loops. And we're going to have a couple different types of loops that we're going to be looking at. But before we do that, I gave you a challenge in the last episode. Let's see how we did on the challenge. So on the challenge, we had several conditions that we were checking with our conditional statements to find out if the zebra was awake, if the zebra was in the pen. And I gave you just those two Booleans, zebra equals true or false, and zebra awake equals true or false. And I wanted you to create a function called checkZebras that would check the conditions of these two Booleans and write a statement on the screen telling us what's going on with the zebra. So let's take a look here at this checkZebra function. And basically we start off checking to see if both of those conditions are true. So you can't quite see it all on this one screen, but it's checking to see if zebra is true and if zebra awake is true. And remember, I could have shortened either one of these by just putting if zebra and leaving out the equal true. But we check both of those first to see if they're both true. If they are, it prints this. Now the next else if says if zebra equals true. Well, the only way it can get here is if zebra is true and the zebra awake is false. It has to be false, or else it would have stopped right here, printed come see the zebra, and then ended. So if zebra is true, we can assume that zebra awake is also false. Then we print do not wake the zebra. And then we can check the opposite of that, else if zebra awake is true, and then this is going to assume that zebra equals false, or else this first statement would have caught it. Then we say the zebra is taking a walk. And then the last case, we can either put else if both are false, but we don't need to do that because the only way we can get here is if both of these conditions are false. So if they're both false, then we put the zebra is sleepwalking. So I hope you guys figured that out. There's a couple different ways to do this. You can do nested if statements. This just happened to be the way that jumped into my head first. So if you got that, good for you. If you didn't, then figure it out, fix it, and ask questions down in the comments if you still have some. But let's go ahead and get ready to get into some loops. All right, so we're going to start off by learning about loops. And the first type of loop we're going to learn about is called a for loop. And it's probably one of the most common types that you'll be using. So in a for loop, we're going to do something a certain amount of times, and we're going to tell it up front what we want to do, what kind of conditions we want it to do, and we're going to be using some of the same conditional type logic that we learned in the last episode to check to see if we have to keep on looping. So I've started off here with just the empty functions here. I did put a CLS in the draw so that we can start off with a clean slate. And I did put in this function here of small donut. Now, if you remember back a couple episodes, we had a donut function that drew a donut up on the screen with 4 different circles. Well, this is the same thing. It's just a smaller version of it, and it's looking for an X and Y. So if I do want to put that in here, I can type in small donut, maybe give it a X of 30 and a Y of 50. And let's test that out. And there's our small donut. So we're going to be using that function just to play around with some more donuts in this episode. So the first thing we want to do is we want to go ahead and make a dozen donuts. So we know up front that we want to make 12 of them. So let's go ahead up into the, let's just do this in the update function, and we can throw it in its own function if we want to. Let's do that. Let's go ahead and make our own function just to keep it clean called make dozen. And of course we need to declare that as a function. So here's our make dozen function. And in this, we want to put 12 of these up on the screen. So we can just do small donut, give it an X and Y, and then copy and paste that 12 times, but that doesn't seem very logical, because what if we wanted to do it 1,000 times? That would not be a smart way of doing it. So we're going to use a loop to do it for us. And I said the type of loop that we're going to be using is called a for loop. So we start off by saying for, and then we have some variable that we're going to use just to count. So I'm going to use I, and we're just going to iterate through this loop. That's why a lot of people use I. So we're going to start it off with 1, and we're going to go to 12. So if you look at the way that that's typed out, for I equals 1 to 12, and in some languages it actually says it like that, for I equals 1 to 12, and I do like that. But with Lua, which is what Pico-8 uses, then we have this, so you can just read it in your head, is for I equals 1 to 12, do something. So just like any other type of function or conditional, once we make some condition for it, we have to have some place for it to end. So in this case, everything that we do in here is going to happen inside this loop for this 12 times. So, and how this actually works is the first time that we initialize this I as 1, it goes through and it does something. And it comes back through at the end, it becomes 2, and it does it again. And it keeps on doing that over and over again until it hits the second number. And as I goes up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, once it hits the 12th time, then once it hits that end, then it's done, and then it's going to continue on with the rest of the program. So I can make these two numbers anything I want. Just know that it's going to start here, and it's going to go this many times, or it's going to go until it hits to this. Because if we started this at 10, it's not going to do it 12 times. It's just going to do it until I becomes 12, and that I is going to increment each time. So now we've got this thing happening 12 times. So what do we want to do? We want to make donuts. So if we type in small donut, and we know it's a function, so we have to give it an X and a Y location. Well, if I just make this, let's say 10, 10, and now I go ahead and take this make dozen function and put it in my draw function so that it happens, what's actually going to happen? We get nothing in the init, nothing in the update, so it's going to clear the screen. It's going to call this make dozen. It's going to come down here, and it's going to make a small donut 12 times. So let's see that happen. Well, that looks like one donut. So what's actually happening here? Well, the problem is that small donut is only happening at this X and Y position. So it's going to make 10 donuts right on top of each other, or 12 donuts right on top of each other. And that's not good. So we want to actually see all of our donuts. So what I'm going to do here is, and this is something that you're going to learn to do and learn to figure out along the way, but I'm going to use this I number here. Since this number is climbing up each time, I'm going to use it to make my X number change. So let's go ahead and keep this at 10. Keep the Y at 10, so it'll still be on that same vertical line, but I want this small donut to be, let's say, if I make it I times 10, then every time, the first time it goes through this loop, it's going to put it at an X location of 1 times 10, so basically 10, 10, which is where it was before. The next time it goes through the loop, it's going to be at 2 times 10, so 20, 10, and then 30, 10, and 40, 10. So this X is getting larger each time that we run the loop. So let's go ahead and run it now and see what happens. And there's our dozen donuts. So now we're using a loop to create, not only create 12 donuts, but we're using the incrementing variable of the loop to place them in 12 different locations. So sometimes you'll have to massage these numbers. Maybe if we had, let's say, 100 of these things, then it's going to go off the screen. We're not going to see all 100 because we only have 128 pixels on here. If we wanted to do even 2 dozen donuts, same thing. After we get to the 12th donut, you can see that 13th donut is getting cut off, and we don't see any of them going up towards 24. So how you can fix this is maybe change this to 5. And now when we run it, we've got our 24 donuts. Some of them are overlapping, but hey, sometimes when you go to a donut shop, they make them touch like that. I don't know if I want my chocolate donut touching my coconut donut, but that is one way to do it. The other way to do it would be to make 2 rows. So let's make 2 rows instead of 1 row of 24 that are stacked on top of each other. So how are we going to do this? If we want to make 2 rows, then this is what's going to be called a nested loop. So we're going to start off with our dozen. We just want to make another dozen in here also. So how do we do that? Well, to nest a loop, all you do is you start with 1 for loop that maybe does something twice. We're going to do 2 rows, and then the second loop inside that is going to actually make the 12 donuts. So I can come up here and put 4, and I'll use j as the next variable, equals 1 to 2, do. And before I get too far, I'm going to put an end on there. And then I'm also going to tab in all this stuff just to make it easier to read. So I've got what's called an outer loop here for j equals 1 to 2. Do this, and then this is another loop that's doing something 12 times. So this is going to happen 12 times, and then it's going to come back out, and it's going to make j2, and then this is going to happen 12 more times again. So let's see if that solves our problem yet. Nope, we still got 12 donuts. And actually there is 24 donuts there, but what's happening? We're coming through here, j is equal to 1. We're making our 12 donuts. And then we come around and we make j equal to 2. And then we make our 12 donuts in the same exact location. So if we do that, then they're going to be right on top of each other again. So let's change our y location and make it based on this j. So if we have j times 10, then the first time it makes the donuts, all of our y locations is going to be 1 times 10, or 10. So I'll have 12 donuts across the 10 line. And then when it comes through the second time around, j will be equal to 2. And all of our donuts will be at the 20 location vertically for y. Now these are still going up across the screen each time. It's just they're making 12 donuts here at y equals 10. And then it's coming to the outer loop. And then it's going to make 12 more donuts with y equal to 20. So let's see if this works. Boom. There's our 2 dozen donuts. So again, sometimes this takes some real noodling out to see what we need to make these numbers here to base our loops off of and make our x and y coordinates increment the way we need to. But as long as you understand the basic for loop, then you know that you can just nest those inside of each other and make them kind of build upon each other. All right, so that takes care of for loops. Let's look at the next thing, which is going to be looking at the stride or the step. So this time when we made our dozen donuts, everything happened from 1 to 12. And I said that this I incremented every time the loop happened. So it went 1, 2, 3, 4, all the way up to 12. Well, sometimes you don't want to count by ones. You might want to count by twos. So you do that by using some languages call it a step, some call it a stride. I think it's called a stride in this one. So let's look at how we can use that. So I'm going to come up here right underneath the draw function and make another function here that I'm going to call countdown. So in this function, we're just going to, what do you think we're going to do? We're going to count down, and we're going to count down from some number down to 0. So let's start off by having some number initialize up here at, let's say 100. And then we're going to count down from there to 0. And we can use different strides or different steps to count down differently. So let's go ahead and just make a simple countdown function by doing a for loop for, I don't know, we'll use I equals X, which we're starting at 100. And we're going to go to, let's go to 1, all the way down to 1. So it's starting off similar to how we started our make dozen, except instead of going from 1 to 12, we're going from X, whatever X is, and we define that up here as 100, down to 1. And we need a step. So we're going to say -1. And let's put a comma in here so it knows that we want that to be the step. So it's saying start at some number, which we defined as 100, but we can redefine that. Go down to 1 by stepping down 1 at a time. So the -1 is going to be the step. So we've got our for loop, which means we have to do something. And we're just simply going to print that number to the screen. So let's print I. So I is going to be climbing down from 100 to 1 step at a time, and it's going to print it on the screen. So let's go ahead and call that function up here. And let's go ahead and comment out the make dozen so it doesn't make our donuts on screen. Let's just run this and see what happens. Something weird is happening. So we can see it's counting down, but the problem is it's counting down and it's kind of getting stuck there. Well, that's because it's going through an endless loop here, and it's happening over and over and over again. And that's because I put this in the draw function. So let's go ahead and take this countdown down. We just want this to happen once. And I'm going to put this up in the init, which only happens once. So now if I do that, now we can see that it printed all those numbers. I'll run that again from 100 down to 1, and then it is clearing the screen. So let's get rid of that. Let's just make it clear the screen at the very beginning. And there we go. That's what we're looking for. So I'll run that again, and you can see that go from 100 down to 1, and then it's just stopping. And I'm doing this on purpose up in the init so that it doesn't keep on looping, because we want to see this happen just once. Well, maybe I want to be able to change this number and over again. So instead of doing this, we learned when we learned about functions that maybe we want to just go ahead and call the countdown function with a number. So I can get rid of this x equals 100 now. And if we do that, we need some variable in here. And we're just going to match that right there. So it's saying call the countdown function, passing it the number 100. And then when it comes here, that number 100 becomes num, or we can call it x, or we can call it y, or whatever we want to call it. And that number gets used in here. So this all works exactly the same way. I just changed the way the function is called. And now that we do this, now let's go ahead and change our step or our stride. And let's make that -2. So it's going to go from num, which is 100, or whatever we call it with, down to 1, stepping -2 jumps at a time. So now when we do it, it happened a little bit quicker because it didn't do it 100 times. It only looped 50 times. And now when you look at the numbers, you can see that they're all even because it's going down basically 100, 98, 96, 94, all the way down to 8, 6, 4, 2, and then we're done because it gets down to 1 and it doesn't even need to print that because the loop is done when it hits 1. So we can make this step or stride whatever we want. We can count down by tens, and then we see it a little bit more logically all in one screen. And you can step up also from, let's say, from 1 to num, and you can use a positive number. So let's use a positive 2. And now we're going to count up. Oops. Forgot my comma. Now it's going to count up from 1 up to 100. And since it started at 1, it's going to go up to 3, and then 5, and then 7. So we're only going to see the odd numbers this time, and it counts all the way up to 99. So we can count up, we can count down, just based on the step. So it all depends on what you want to start with, what you want to end with. Sometimes you want to count down, sometimes you want to count up. But the premise is all the same. We're using a for loop to make that happen. All right, the next concept I want to show you is, instead of using a for loop, we're going to be using a while loop. So while, W-H-I-L-E. So let's go ahead and comment out our countdown. Make a new function called, we'll go ahead and use this as the count up. And define that as a function, of course. And now we're going to count up, but we want to count up and we want to be able to stop it and start it. So how are we going to stop it and start it? How are we going to make it start counting like a stopwatch and then stop it and then start it again and stop it and start it? So what we're going to do here is we're going to have a variable that we're going to define up here as keep counting. And that's going to be a Boolean. And as long as keep counting is true, it's going to start counting up. And if this ever becomes false, then it's going to count down. Now we could do this with if-then statements, but we don't want to do that in conjunction with a loop. We can just simply make a loop that will do that for us. So we're going to use a while loop. So while, you can see as soon as I type it in, it turns this pink color, which means it's some kind of command that it understands. And we're going to say while this condition, I'm going to say keep counting, I think it was all one word, equals true. Everything, so while, and it's going to look at everything in these parentheses, and sometimes you want to use parentheses around it, sometimes you don't. I usually try to use it just to make it easy. I know that this condition, everything inside here has to happen. So while keep counting equals true, now we have to do something, just like the for loop had to do something. Now we have to do something. So this is a loop, so I know that if we start it with a while, we have to end it with an end. And then everything in here is going to happen. Let's make that a comment. Happen while keep counting equals true. So as long as this is true, it's going to keep on happening, and this loop will just go on and on and on and on forever until this condition is not true anymore. So what are we going to do? We're just simply going to print a number. Let's just say print x. Let's start off x at 1 up front here. And right after it prints it, we're going to make x equal to x plus 1. So we're just going to increment that. Remember, we could also make that x plus equals 1. That's a shortcut for x equals x plus 1. But basically, once we get into this loop, we're going to print the number, which right now is 1. We're going to add 1 to it, so now it's 2. It's going to come to the end here. It's going to come up to the while thing. It's going to check this condition again. Are we still, is keep counting still equal to true? Yes. So print the 2, make it 3, loop around. Is it true? Yes. Print the 3, make it a 4, come around, and it's just going to keep on counting up. So let's see at this point, if we call count up, if that works. And there we go. So we started at 1, and we're counting up, we're counting up, we're counting up. And it's never going to change because I've got no way right now of changing that condition. So the only thing I can do is hit escape to break that loop. So I want some way to change this condition. So what I'm going to do is I'm going to put something right after this that will allow me to change this keep counting to false. So I'm going to put a simple if statement. We learned about those in the last episode. If, and I'm going to use a button press, BTNP, which is button press, and we'll learn more about these later. And I'm going to say, let's say X. That's a Shift X, which just makes a fancy looking X, which is one of the two buttons. You can go up, down, left, right, and then you can hit Z and X, or 0 and X is what they call them. So if button press X, then let's do something in here. So look, I opened up the parentheses to get the full condition in here, and then I opened it up to check the button press, what I'm actually pressing, and then I close the parentheses. So it's important to make sure you have matching opens and close, or else you'll get an error. So right after we get into this loop, we're going to say, if someone hits X, the X button, then we're going to change keep counting to false. So if I get into this loop and I hit that button, it's going to change this condition. It's going to go ahead and finish this out here. And then it's going to come up here and check that condition. And then it's not going to be true. So it's going to jump out to this last end here. And then we'll be done with the function. So let's go ahead and hit that run function, run. And we're counting up, we're counting up, counting up. Let me hit the X button right now. And now it's done. So the game loop is still happening, but the while loop is done. So let's hit escape here. Let's test that one more time. Run that, hit that X button, boom. But if I hit the X button again, nothing happens. Maybe I want to be able to toggle it on and off. So instead of making this button press, just hard code this variable here to false, let's just make it the opposite of what it was. So to make something the opposite, and it's a Boolean, there's only one opposite it can be, we're just going to say make keep counting not keep counting. And this is just a fancy way of saying whatever keep counting equals, and at first thing it happens, it's true, make it the opposite of that. So it's false. The second time I push this button, it's going to say make keep counting the opposite of false, so it's going to be true again. So if I got this right, I should be able to run it. It's going to start counting up endlessly. I hit the X button. It's going to stop. If I hit the X button again, nothing happens. So I hit the X button, X button, X button, nothing happens. So what is happening here? So we went through here, it was true. We hit the button, we made it false, and then it looped around. And as soon as it saw that it was false, it jumped out of this while loop, and then it was done. So because this function is being called in the init, and it only happens once, then once it fails out of that loop once, it's just done. So let's see what happens if we take this out and maybe put it down in the draw thing here. Let's see if that will happen. Okay, well that didn't work. And what I accidentally did was I put basically an endless loop here inside an endless loop. So this draw loop is endless. And as soon as I hit go, this thing is endless because I can't hit this button fast enough. So that's not a good idea. So scratch that whole idea about being able to toggle this on and off. The better way to do that would be to have this if statement up in the update function. And instead of using a while loop, just use the endless loop of the draw to do what you want to do. So sorry for wasting your time on that, but I just wanted to show you just the differences between a for loop, which goes from some predefined number to another number, and a while loop, which is basically just an endless loop as long as or while this condition is still true. So we can stop it by making this false again and taking this count up out of here, putting it back up where it's supposed to be, and only happening once. And now we can start climbing again and hit X to stop. So another way that we use while loops a lot is to have some number that it's checking against, and it would look something like while X is greater than 100, do something. And this X number may be affected by other things. So maybe this is the coordinates of a character that's running across the screen. Maybe this is a number that's being computed with math, and we want to check to make sure that it's staying within some bounds. So you'll see this type of while loop used a lot also, because we don't want to make the loop happen 12 times like when we made our donuts. We want it to happen as many times as it takes until the condition is not met anymore. So that's a while loop. And some programming languages actually have what's called a do loop, which instead of doing a while something do something, it's the exact opposite of that. It says do something, and then it checks at the end while something is still true. So as soon as it gets into the do loop, it'll make something happen, and then it'll check the condition at the end of it. So I haven't used that particularly in Pico-8, but I'm sure it probably works somehow. But go ahead and test that out and see if you can make a do loop. So that's going to be all the concepts that we're going to be working on in this episode. We made basically a for loop for our donuts, and we made a nested for loop by making 12 donuts on the inside or the inner loop, and we made that twice by having an outer loop. So we made 24 donuts. Then we learned about the while function or the while loop, which is going to do something as long as this condition is true, and it's just going to keep on happening until we stop it somehow. So with all that new information, let's go ahead and make a challenge. All right, for this week's challenge, what I want you to do is take what you learned about loops in this episode, and we are going to print multiples of the number 12 on the screen from 0 to some number that you define. So if we look at what I've got here, I'm printing 0, 12, 24, 36, all the way up to 192, and I did that by calling the function 12s, which you're going to write, and passing the number 200. So if we change this up to 2000, it would do the same thing. It's just going to count by 12s until it gets to the number 2000, or just before 2000 in this case. So you're going to clear the screen. You're going to have some function called 12s, which is going to loop through some numbers and print something on the screen. And it may be a little tricky how to get them to land on exactly the multiples of 12 like this. But if you just think about what happens, do some trial and error, and play around with the numbers and the print statements and the loops, then see if you can make this happen. So starting with 0, going up to whatever number that you want, even if it's super huge, and going up in sequences 12 at a time. So have fun with this challenge. Good luck. If you have any questions or get stumped, ask me in the comments below. I'll be happy to give you some hints. So that is going to wrap it up for this episode. Hope you enjoyed it. Remember, if you are enjoying this series of tutorials, then go ahead and hit the like button so that I know that you're watching and that you're enjoying it. Don't forget to subscribe, because this is the last scheduled Pico-8pril episode. From here on out, we are still going to be doing some more episodes, but they're not going to be every Monday and Friday. I'm just going to throw them out in the coming months, just as needed. So if you have any ideas of more stuff that you want to learn, we have hit some of the major basics of programming. We did a little bit with graphics. We did loops. We did conditions. We did print statements. All kinds of fun stuff. Learned all about variables and strings. So if you have some requests, throw those down in the comments below also, and I'll be happy to take those into consideration. But do make sure you subscribe, because these are going to be coming out instead of on a scheduled Monday, Friday type situation. They're just going to be coming out whenever I get a chance to make a new one. So thank you as always for watching, and until next time, peace out and geek out.